This is another interesting topic for me. I think I got interested in it because of Damien Gatinel. He was my mentor. It was kind of serendipity because my husband got a fellowship position as an interventional cardiologist in Paris. And he called me from Paris and he said, they've offered me the job on the spot. And I said, but I'm at Moorfields, I'm doing well. Like, why are you trying to spoil my career? And then literally 5 seconds later, I was like, hang on, you want me to move to Paris for a year? I think I can do something. And so I decided to quickly, mobilize everything, took a out of program experience time and took the leap, emailed Damien, and within a couple of days, he said, yep, you can come. And initially, I was going to work for free. I was going to do all the research with him for free. So I was saving money. And then in the end, 2 weeks before I got there, he actually got me a salary too, which was amazing. So he's an amazing mentor. And I think he really sparked my interest in refractive surgery, in AI. And when certain opportunities come to you, take them. Just like you've taken the opportunity to come here and be a part of this amazing team. So I don't know what the general standard knowledge of AI and ophthalmology or generally AI is here, but I'm going to talk through from basic very fast to higher level. And I think probably because most of you are fellows, you'll already be aware of things. So the first thing is to know your environment. Okay, we know about AI, but do you know that it sits within a whole mixture of things? Your imaging devices, your Internet of Medical Things, your telemedicine, even the 5G and 6G networks that are being developed, all of these things. And by the way, I'm going to share all these slides so you don't have to write anything. Just know the environment. Now, we already know I'm shouting, Alexa, put on my favorite music. Siri, what time is it? You're in your Tesla, you're driving and you're using AI. It's already all around us. We're already submerged in it. But why is it that we're interested in it now? Why are we trying to utilize it at this moment in time? AI has been around for a long time, but there wasn't a pain point to fix. Now people are living longer. We have resource poor countries where you're having to be very innovative in the way you deal with patients. And actually, it's pushing you towards AI more than some of the Western countries into telemedicine, into discovering these technologies. I found out you're doing a lot of actually AI projects here, which is incredible. We have long waiting times, even in the UK. Now it's better, but still for corneal transplants, it's several months. It's not easy. There's higher expectations. We are getting amazing lenses. You're creating your own lenses, I found out. Patients are expecting more and more. They didn't have this before. And then, of course, advancing technology. And now we have amazing imaging techniques. You have abilities to for diagnosis, for documentation, for post-op and pre-op planning. Oh, I've got that 6'5" patient who's still unhappy. That's the level of work we're doing now. We're no longer worried about the other patients because we're doing well with them. And there's lots of different types of imaging that is getting more and more high end. Okay, so you have your EMR, you have your higher imaging quality and faster computers. But what does that give you? Well, it gives you extremely well-organized data sets that are anonymized. But what are we doing with them? Most of the people are doing nothing. Roberto Zaldivar said, data is arguably the most important resource in healthcare today. And I'm sure nobody doubts that. This is the example of how many publications of AI and ophthalmology that's happening right now. You can see that there's a huge spike. And that other one at the end is already, I think it was in the first 2 months or something of 24. So it's huge. Okay, so who actually can say confidently, I know what AI is, I know what machine learning is, deep learning is, auto ML is, and also I know how to read an AI paper and decide whether it's applicable in my own clinical practice. So show of hands, how many of you feel at the moment already confidently that you can read an AI paper and decide if it's clinically relevant in your clinic and whether it's applicable? Okay, so can somebody tell me what you think artificial intelligence is, if you were to ask to summarize it? Anybody? And it's okay. Honestly, there's no stupid answer because at the beginning, when I started looking into this, I had no idea. My husband's extremely smart, mathematical, and he always laughed at me. He's like, why are you doing work with AI? You don't know anything. But I learned. So there is a stepping. What do you think it means to you?
So, computer generated intelligence, other than the normal human being, what brain It's not like a human intelligence. It's a computer generated intelligence.
Yeah.
Like that.
So actually, AI in the real sense as a human does not exist. When they're talking about AI, they're talking about machine learning. And what is machine learning? It's basically saying that, okay, I'm going to present the computer with so instead of putting the explicit programming where you tell the computer, this is a bird, this is a dog, instead of that, you're showing the computer these images and you're saying, look at these images, and you give weighting. You know, like how you have weighting of coefficients? Like that, you give weighting to certain features. And then you say, okay, that thing has a beak and that has ears. Okay, so you give different weights to it. And soon the computer learns the difference between the two, right? And then you show it another set of images, and then it says, oh, I know what that is. I think that's a bird or that's a dog. That's literally the basis of machine learning. Okay. And what do they mean when they talk about deep learning? That just means that it's got layers of this learning algorithms. And those layers are interconnected, much like neurons in the brain. Okay. And that's what machine learning is. And it's actually, you can code, you don't have to be a coding specialist to understand this. I started learning Python coding, but I'm not an expert in it at all by any means. But you find the people that can code to work with you. But you have the clinical expertise. So a coder can't do what you can do, and vice versa. Well, maybe not, because some of my ophthalmology people are coding actually. And then the next step is auto ML. Who knows what's automated ML? Okay, good. I'm starting at the right level. So automated ML is actually where it's a ready-made machine learning algorithm, which you can tweak to suit your thing. So you don't have to be an expert, and there's lots of these available. So let's go forward to trending words: ground truth, training sets, test sets, validation. Ground truth is what your expert labels that dog or cat or bird as. And then there's a training set, which trains the algorithm, and then a test set, which must be kept segregated. And usually you use 20%, or sorry, you use training set 80%, and then 20% you use as a test set. And those should never be on the same computer. They should never be meeting at all. They must be segregated. And then you test and validate whether that algorithm is correct. I'll tell you something interesting about that later. There were some landmark moments, and actually you guys are already working with Google DeepMind, or Google, I believe, to do some interesting AI stuff. And actually that's where it started. Google DeepMind worked with Moorfields Eye Hospital with my colleague Piers Keen, and then Microsoft with Bascom Palmer and my friend Rania Habash. And then of course, FDA approved the first AI-based software as a medical device. And that was a turning point, because now suddenly it's like, okay, getting noticed. And we talked about this, the data, the training the machine, the building the model, and predicting the outcome. This is a simplified version of it. This is a little bit more intricate. This is showing you the inside the bonnet of the car. Okay, it's showing how you have to pre-process the data, engineer the feature, extract the feature, algorithm selection, hyper-parameter optimization. All these words should become part of your vocabulary if you're going to be looking at AI. You have your raw data set, and then you have your deployable machine learning model, but there are all these steps in between. And there's lots of auto ML based platforms. And actually at the moment, we should be taking advantage of them, because they're free at the point of use. Soon they won't be, much like ChatGPT. So auto ML means you skip all of that and you go straight from the raw data set with a little bit of work to your deployable machine learning algorithm. So what's the application for us? Actually, in Cornea, there's lots of things happening. You're already talking about taking imaging and being able to detect whether this is a fungal infection. Do we need to start natamycin straight away? Or do we do the usual moxifloxacin and wait to see the patient deteriorate in front of your eyes and then do the standard thing? It's difficult. This is one example of an image which was just normal corneal nerves, okay, an in vivo confocal. And A is which was shown to the computer. B is where the expert draws the lines for the computer, delineating the density of the thing and everything. And then C is the image another image being presented to the computer, and D is what the computer draws without knowing. And so soon enough, if you add your age, your diabetic status, your previous history, and these images, you can suddenly say, is this a healthy patient or unhealthy patient? Do they have diabetes or not? And we might be able to predict lots of things, just like with iris recognition and other things, retinal imaging, and figuring out if someone's going to get dementia in 7 years. So much is happening. So be aware that there's lots of areas of interest in cornea. This is a paper that we published in 2020, which kind of gives the real summary. And actually, we created a table so you can be really lazy and just look at the table and then look at the references to what is happening at the moment. And there's a QR code there, but I will share the thing with you so then you can use it later. So what's happening in cataract surgery? Well, we're segmenting it into screening, intraoperative care, and postoperative care. We're grading cataracts. We're actually using tools in our OR, and turns out you guys have a very good technique of looking at how your surgery is being performed. You don't need a Zeiss, 100,000 pound injection of cash just to segregate where the capsulorhexis is starting, because the surgeons are so lazy to watch their full surgery because we don't have time, because we're too important. No, it's not true, So actually, you're already doing this. And then the post-operative care, you have, I don't know if you have this here, but you have some AI-based telephone systems now that call the patient on day one of cataract surgery, post-op, and it automatically asks the right questions. And then if the patient is not answering correctly, then it goes, and it's doing quite well. So these are quite interesting applications to be considered. And then, of course, in refractive surgery, we're predicting, we're detecting, we are enhancing accuracy, predicting risk of post-LASIK ectasia with brain, which is Renato Ambrosio's work, and then, of course, our work on Pearl DGS formula. So these are some of the AI-based papers that I have written with Damien or with colleagues thus far, I believe. I think maybe I've not updated it, this slide, actually. Maybe there's a couple more. So we've been working on quite a lot of things. And that's the best way actually to get into AI, is to write about it, read about it, submerge yourself in it. So what are the current uses? What can you be using right now on your phone? I use this all the time. So when I have a patient who's post-LASIK, I reach for the Pearl DGS formula. How? It's free. IOLsolver.com. You log on from anywhere in the world. You type in your keratometry. You type in, if you've got an IOL Master 700, which you do, you can type in the lens thickness even and the CCT. It's even better for the algorithm, and it predicts the lens. And guess what? The last 5 patients I've done post-LASIK are all 6.5, 6.6, etc. They're doing extremely well. So I truly believe in this, but there are others. So don't just trust and take my name for it just because I may be biased because I'm using Damien and our calculator. There's lots of calculators out there, but embarrassingly, my hospital is still using SRKT, whereas in more fields, we're using Barrett. I mean, when I say it out loud, I feel like, oh my God, don't judge me. But guess what I do? I use the SRKT. I'm like, yeah. And then I check on the Pearl DGS. And then I'm like, yeah, that's correlates, it's fine, But at the extreme ends, SRKT starts deviating. Of course, it works well. Nobody's noticed a problem because we are treating NHS patients. They're not coming back with 6.5 glare. They're happy 6.9, happy 6.6. Yeah. So get to know these AI-based power calculators. Get to know what are the main parameters of them. Yeah. Because at the end of the day, this is the future. This is where it's going. It's going to even surpass Barrett and other things. And now the great thing is that, great thing is that now you have the ESCRS web scraping, where you actually don't have to re-input everything to see what different IOL power calculations are showing you. So you don't have to go to IOLsolver.com. You just go to the ESCRS tool and you type in your numbers, and it just shows you all the different power calculations. So you can compare. Why would you type in for 1 if you can type in for 7, right? So these are things that we should be doing right now. And in fact, I've embarrassed as I was, I decided to take action, and we're actually doing a big audit of about 250 patients. So I can prove my point by using the ESCRS calculator. The only problem is we auto-refract our patients and don't properly refract them, which will be the issue. But still, we need to get an idea, a sense of what we can do. So I showed you that image before, okay? So now let me show you in action what it looks like. That's what it looks like. So this took us 3,000 hours and 3 years to develop the Pearl DGS formula. I helped in my own way when we were trying to figure out whether we can use it for multifocal lenses. I entered, I think, 700 patients' data or something. In the end, that's on the back burner. We didn't quite get there. Now we're working on the monofocal is working well, and now we're working on the toric. But a lot of work went into this. And so you can see the inner workings, okay? And so we have a Pearl DGS. It's a prediction enhanced by artificial intelligence and output linearization. I wouldn't have thought of it like that, but Damien likes to complicate everything. This makes it really difficult. One time they asked me on the podium, what does it mean? So now I put it at the top because I can't always remember. But the DGS is a Debelmanier, Gatinel, Sard. So Alain Sard, Damien Gatinel, and Guillaume Debelmanier. Guillaume is our real brains behind it with the Python coding. So he's an excellent corneal surgeon and he can code. So the Pearl DGS is doing well, and we are now constantly testing. And of course, everyone will show their own formula. You'll see different papers will have like, oh, Barrett 2 is better, or Evo is better, or Kane is better. And who's showing that the Kane is better? Oh, it's Kane. So just be aware of that bias. Of course, I'm showing you the best, but I'm also open to the fact that we are all biased a little bit, but we are actually sending out we're saying, send us your data. We'll assess it for you. Or you assess it yourself and tell us how you're doing. Publish it. We want to know how well we're doing. We want to improve. We don't want to be the best. We just want to improve. So this was the IOL calculator. And then, of course, there's lots of work being done in brain. And I don't know if you have the MS39 here, or which anterior segment OCT scan you have. You have what, sorry? Okay, yeah. So the MS39 and even some of the other ones like the Anterion, they have AI-based detection for keratoconus, which is quite interesting. I mean, to be honest, it's good because, the technician or someone can say it's flagging this up, but actually most of us can tell now, especially if we're using epithelial mapping, which everyone should do. Sorry. Okay. So, do you do epithelial mapping here, by the way? You do epithelial mapping? Yeah. So that's yeah, because really, oh, thank you. So really, epithelial mapping has been a game changer. And of course, Dan Reinstein has to talk about it every second that is not sleeping. He's talking about it. One time he actually made me sit next to him on a plane and then went through all the, he made me change seats. I was like, I'm okay. No, come sit next to me. Let's talk about it. Okay, fine. Anyway, so what are the implications and future? Okay, well, the future is looking very bright. Actually, the things we've talked about so far are already being done in many places. We just haven't adopted it. This is some work that Pooja Kumar and Rohit Shetty are doing with their Grow Labs. And I think they're using some AI-based software to be able to figure out biomarkers. Very interesting. Ikiru in the East, he's doing lots of work in AI. If you type in Ikiru, you'll see all these amazing work pieces. They're not even checking the patient. They have like these machines that they're planning where everything is done and it throws out an explainable machine learning approach. Why have you said that patient should have a LALEX or SMILE versus LASIK or PRK? Very interesting. And I think that could be the future for refractive surgery. And then bionics, well, actually, they're not doing so well. They found that actually putting the company themselves told me that when they put the headset on, they flick their head to the right, so that's meant to bring up the pentacam scan, and flick their head to the left, but apparently it was going haywire and doing weird stuff. So let's not use it yet. But when it's ready, it'll be very impressive. And then there's lots of other ones, like what's the risk and the prediction of spectacle independence and visual field outcome. And then, of course, there's robotics. Robotics is really going forward, and you're seeing, new things being developed at the moment. I think Precise in the US, and they're looking at, having a robot insert the thing. Maybe they'll start doing the injections for AMD. You never know. That's the future. And actually, yeah. Oh, great. Yeah. So, oh, great. So you have to tell them that I came and talked about them. So it's really quite interesting. So it's all well and good understanding the basics of artificial intelligence. I think your son is in AI as well, correct? And it's good that you actually already have. You're probably bringing him in and teaching them a bit more about it as well. But there's a disconnect, and again, it's all about application. It's all about why is not everybody doing it? And it's because we understand the benefits. We understand the improved accuracy, the efficiency, the personalized patient care. But there are these perceived risks versus real risks. And that's when it comes into it. Bias in training, lack of transparency. The Pearl DGS is the only open source code. So you can actually go in and click and look at the code. Everyone else, we don't know. You ask Barrett, you ask anybody, they're like, oh no, it's a secret. It's top secret. What's the point? Yeah, what's the point? If you're not sharing it, I don't know I can trust you. I'm using it because the results are good. But at some point, something changes and my patient gets a bad result. Who am I going to blame? Myself. I'm the clinician, right? And then there's the data privacy. We're sharing all our patients' details. It's going everywhere. Is it going to be used against them in the future? And then ethical considerations as well. So these are things that you should just, again, have in your vocabulary as something to think about when you're reading these papers. So there are actually standardization and guidelines being developed, and you should know about these three: Consort AI, Spirit AI, Start AI. They're looking at standardizing the way that these things are reported, standardizing the way that we're doing interventional trials in AI. We know how to do normal trials, but do we know how to do AI-based trials? Not so much. So AI may solve the clinical problems, but we have to design the questions. So the question is, do you think that we're going to be replaced by AI in 5 years, 10 years? No, not a chance. But I know who will be replaced: people who don't know about AI. So if you're AI literate, you'll be fine. But if you're AI illiterate, you're gone. Because we won't need as many, or we will need more because the eye care, the burden is increasing all the time. But we'll need people of high quality who know this. Rubbish in, rubbish out. This is key. It's that if I was to put 20 X-rays and mark left and right, leave that mark at the top that says left and right, and then the algorithm comes out and says, I can tell whether this is left or right, but you've forgotten that the mark is at the top. That's rubbish. It's useless. Yeah. So you have to really know that your image that you're inputting is of a high quality, of the right quality, and not mislabeled. And the key word is collaboration. We have to collaborate with optometrists. We're not just only ophthalmologists that are doing AI-based stuff. You have to work with the entire team. Just like you will leverage the right people for the right thing, we have to use them as well within AI. The question is, are you AI ready?